Hello everyone. So this is the starting of detailed refinement using FullProf. But I mentioned here it's before introduction. I'll introduce FullProf basics after this video. Why I did basically this video before introduction? I need to say something. So uh, after uploading first video, I got a number of responses, and I'm happy to have those responses. In those responses, many people say thanks for uploading, and yes, I'm happy with that. Now I got some requests also. The request I have listed here. So one student asked whether I can organize a workshop. I'm really sorry, I cannot organize a workshop for you. It's difficult for me. Then tutorial in more details. Yes, I was thinking, and in fact I started uh, writing on the website. Some of you have already visited that website, easywayhowtodo.com. I started writing, but after 1 or 2 weeks I found that it will be more useful in video other than in text. So I stopped that. Maybe I will continue after making these videos. So simultaneously, if you use uh, video tutorial along with the text, then that will help you more. uh, then video tutorial with voice. Yes, I didn't uh, give voice in the previous video. Why? I'll discuss at the end of this video. Then users experienced several issues, technical faults. So they are asking about those things. Uh, some of the faults I can solve, but I'll not make a video for these things. What I'll do in the course of tutorial, uh, time to time, I'll show several mistakes. I'll be doing mistakes. Like out of 100 mistakes, you can consider 80 mistakes will be created by me. Planfully I'll create, and I'll show these are the wrong things, I have to do something. So as a user, how you will rectify your problem, I'll show that way. That means I will be doing everything as an user, not an expert. And in fact, I'm not an expert. Then specific problem, some specific problem will be there, always will be there. So those things you can comment, and I'll be answering time to time to those comments. But I need your patience because I have some other work also. So sometime I may take few days to answer you. So thanks for your patience, for asking questions, for watching videos and waiting for this tutorial. And those who subscribed, those who like videos, I'm really thankful to all of them. And these are the things which give courage me to do more on these topics. So I'll continue, and depending on your responses. So really I'm thankful to you, all of you. Now let's start. Let's start mean you should not be ready for running first. This is the procedure where never ever you should try for going fast. Instead, you should go for like slow, steady, with better understanding. So this is not the way. The way is you have to have patience. You have to continue. Even if you fail many times, you have to continue. And each time you have to understand. Each step you have to understand what is happening. Your understanding and my understanding can be different, and mine is not absolute. You may find difficulties in my understanding, and you can modify, and you can comment me. So yeah, it's very silly, like understanding. So yeah, what I'll be telling that may look like very silly. So yes, I'll be very silly. So this is the warning that This particular tutorial is not for those people who are already using and who already have it, like familiar with Rietveld refinement. This is for the new people, new students who are just started or will be starting soon. For them, it will be useful. So others may ignore this video. Now, these are the things always you should keep in mind. Don't think that I'm expert, and I'll be doing as a learner in all the videos. And really, I don't know the very, very important things maybe. And yes, I don't know. But what I know is uh, how to get refined, how to get values, how to get work done. And I'm a very lazy person, so my way you can consider is the easier way. That's what I can say. And this is a way of sharing experience. So if you have better experience, please, please comment. I'll be happy if you find out mistakes, if you correct me. Uh, so by that way, uh, you can confirm whether what you learn is correct or not, and you can teach other, and same time I'll be enriched with your knowledge. So what do you do? We, then I'll be make some sample, some material. Then what we do? We go for study and we get some data, some reflections. Then we try to find out the material information. This is result. So from here, what we are trying to know structural information. Yes. So what structure is it, and what are the parameters like structure name, space group, then ABC parameters, etc. So many parameters are there. So we need to know these things. So what we do generally, we search for the similar materials on internet, on several books. So we try to find out if these reflections are matching with any other uh, results, known results. In fact, for some of the students, they will be making the same materials what already made and what the XRD of these materials already published. So uh, for them it will be easier to compare. If it's exactly matching with the previous result, then it's done, because already reported result will be having all the information. So if your pattern is matching with those reported pattern, then you can assume that all these parameters reported are the same for your material. But some people will be trying for a new material or a new structure or little deviated from the ideal structure. So what then? Then come refinement. So if you like, when I started, I also thought like that, right? So I make sample, then I did XID, then I try to find out structural information. So this is what refinement is. Yeah, in one way it's correct that this is the way we are doing refinement, but I really want to say no, this is not the way how refinement is happening. Refinement is happening not in as the arrow is pointing, but it's happening in a very complex format, complex way. So what are the things, key factors? Information about your sample, estimation about your structure, sample structure, crystal structure, then matching. Matching, already I started talking about matching with older reports, other means earlier reports or something, or estimation what we have estimated. Then indexing. If so, you will be matching your estimation with the experimental value and indexing. Yes, this was the first or basic of refinement. Yes, I know, and even I didn't consider this as refinement, but actually, this is the refinement. Now, as your system is more complicated, you need more information, and then you need to go for higher level of refinement. That's what it is. It's an algorithm or code, computer based, obviously, which will be generating a pattern, XID pattern. Yes, for that, it needs some input, that is information. Don't think again that you will be giving an XID data, it will be doing refinement. It's not exactly that way. It's happening. What is happening? You are giving some information to the software, and it will be generating depending on its instruction. It will be generating a pattern. Now, what pattern you got, you have given to the software to match it, not to generate or not to get any information from it. You have given the XID data to the software for matching with the pattern generated depending on the information you have given. So that is the important thing, matching. Now you can see what I have generated is not exactly same what we got from the experimental data. What we'll be doing then? Next, we have to change our information. Maybe our information was wrong, that's why the generated pattern is not correct. So we have changed the information. Now again we'll be generating something, but it's not. We have to tell the software something else other than the information, because I know so far these are the information correct. So why it is not generating? Then it may take something else. So those are the instruction. You have to give some instruction. You have to tell how to do it or which way you want to do it to generate the data. So there will be many instruction, and again you have to change some information. This you have to do many times cyclically to reduce the difference between the generated pattern and the experimental pattern. And once for some certain number of instruction and particular some information, it will generate exactly the pattern which you are looking for. I mean the exactly similar pattern what you have got from your XRD experiment. If the XID pattern generated from the software and from the XID experiment matches well, then the information you have given to the software to generate the pattern is the information what you're looking for in your sample. That means those information are equivalent to the information hiding in your sample. That's requirement. Now, if this is the basic, this is the whole of refinement, then we found four basic things. I mean, four important things. One is information. What information you are giving to the software to generate the XID pattern. This information can be known, some of the things you already know, some of the things you assume, some of the things are totally unknown. So what is your target? To make confirm the assumption and to find out the unknowns. Known things are already like elements, experimental conditions. I mean, the XRD system about something about XRD system. I mean, um, the XRD machine, in which way it is doing. Then, what is the source and detector distance? What is the source and sample distance? What was the error in theta? Like that. Then excitation used, whether it is XRD or neutron or synchrotron radiation. That and sample information, like you have targeted for particular structure, or there can be some other structure, or there can be some oxygen deficiency, you have created oxygen deficiency already. Then assumption, structure can be assumption or known. Then parameters of the structure, you know, ABC parameters approximately, and you want to know the exact from your sample. So that's what refinement stands for. Then deviation from the ideal structure. You're thinking for a cubic structure, but it is not actually cubic. It's maybe little bit deviated from the structure. It's not cubic. It's instead of 9 degree gamma instead of 90-degree become 89.9. Who knows that? But that's what you have to find out from refinement. Then unknowns are unknown. So how we will tackle the assumption and unknown? You can try. You have to try again and again. You have to assume something. You have to run the program. You have to try. Now here's come the important thing: the algorithm or the software. So I know there are many commercial and free softwares. I'll be talking about only free softwares. So I like two. One is mod, second one is foolproof. Jesus, I know, but I feel somehow it's very backdated. Um, anyway, if you're using and it's good, good continue. So methodology and software is the thing. Methodology means what we'll be using is Rietveld refinement. I mean, what Hugo Rietveld proposed or showed us the best way to do refinement. Then software will be using mostly foolproof if it's necessary and when it is necessary. Also, when it is necessary to use mod, so we'll be using mod then. Restriction and instruction to the system. Yes, how many cycles it will run, what are the instruction, how it will do. It can do different ways. Then what are the things it will you are asking to software to do, and what are the things software will be doing wrongly, and you want software to stop that, and you want to do it manually. So these are the things. In matching, yes, it will be generating. I told already that it will be generating one theoretical pattern, and you have your experimental. You have to reduce the difference between these two. And when the difference between these two is minimum, your refinement is done. So this difference, you have to know all these parameters: RP, RWP, RXP, etc. And finally the chi value. So chi value you have to reduce. You are reducing chi value means you are reducing the difference. When you are at the minimum of chi value, your refinement is done. Yeah, then you can accept. So this is the process. Cyclically it will run again and again. Will be running again and again. So what are the requirements for a successful refinement? Yes, these are the things. Information, you know more information, it's easier for you to refine. Assumption, you have to develop your logical assumption, not abrupt. So you have to assume something based on your knowledge, based on how software is behaving, and what are the information you have. Then software already you have decided foolproof. So um, no need of discussing further. Then yes, obviously optimization and logical analysis. Yes, in each step you have to analyze what is happening. It will help you to develop your expertise in foolproof refinement. So each step, why you are changing, and if you change, what is the change is going to be. If you change ABC parameter, how reflection will stand, which intensity will decrease, which peak will shift. These are the things. If you do logically, you will know one day. You don't have to read book for this. There are many books. Those will show you that this is the stress group. ABC are the parameters. If you change A increase, then this peak will get shifted. This intensity will go. The other intensity will go down. Like, but if you do it logically with foolproof, you will understand which parameters stand for which thing and how it will influence the result. Uh, so introduction part is over. Now I have to introduce foolproof. Yeah, you know already, but as I'm doing step by step and thinking about all the viewers, so I'll not be skipping any step. Now, uh, I'm thinking today I'll be stopping here, and next tutorial I'll introduce foolproof with its uh, ability and inabilities, and problem with foolproofs and benefit with foolproofs, and what are the things you have to always remember. You should not forget if you are using foolproof. Those things I will introduce next time. Uh, So I'll be looking for your response before uploading the next video, introduction to FullProf. What I'll be looking for is this. In the first slide, I told that uh, why I didn't include voice in the previous video, because uh, yes, you may laugh. I was uh, quite afraid of my voice. My voice is not that good for a video presentation. So I want to know from you whether this voice is okay for you, whether I should continue or I should not use voice. Instead of voice, I can use text box, text instruction. And I'm really speak English in very poor way because English is not my mother tongue, and I don't know very good English. So the three things you have to tell me whether I should include voice in next video, and whether the English is okay, and mainly whether these videos will be useful for you or not. Shall I continue or not? These are the things I really want to know. Then once again, thank you everybody for watching. For thinking this is not good, please comment. If you are thinking this is good, comment. And what is your opinion and how I should go? Because this video and the next video will be coming for you only, because some of you requested for this. So I'm trying. I do some other work also, so it may take some time. And if you comment also, it may take some time to respond you, but still I'll be with you, and if you're with me. So yes, thank you once again. I'll see you in the next video.